Today let's go over a medium that I finally managed to solve by myself, so I'm pretty happy about this. It took me quite a few tries and time limit exceeded to realize and come up with my own approach, so I'm going to show you. So the question is pretty simple. You're given an array and it's considered special if every pair of adjacent elements between this subarray is going to be like not the same, like both can't be odd or both can't be even for every pair. So basically we want to determine that, and if it's not following that rule, we do false for that particular subarray in queries and otherwise do true, and then return this Boolean array at the end. So the brute force approach, which I was doing before, let me just show you. Let's declare a result that we're going to use, and I'm going to return a list of Booleans. So basically you go through queries, and then the start and the end is Q0 and Q1. And then now you can just go through nums. So from start to end plus 1, because that's the subarray, the boundaries, and use a flag. So if, let's say, nums of, well, let's just call this current, is equal to nums of start to end plus 1. Let's print current to make sure. Okay, so 0 through 4 inclusive, 0, 1, 2, 3, 4. And then now we can just use a Boolean flag for I in range 1, length of current, if current of I modulo 2 is equal to 0, and current of I minus 1 modulo 2 equals 0, or current I modulo 2 is not equal to 0. So basically they match in terms of even and odds, then that's a violation. Flag equals false, and break. And at the end, if flag is true, then that hasn't been violated, result.append true. Or we can just result.append flag, which is either Boolean, and then just return the result at the end. So this technically works, but it's really slow and squared, and they don't like that. So we're going to come up with a better way to do this, which I'll show you my way. Okay, as you can see, you'll pass everything but one last test case. And so now, instead of doing this, if I just took what I was doing here and I said, okay, let me pre-compute these values. So let's declare an array of the same length as nums, and basically if we see any mismatch between the pairs, then we're going to declare the last one as 1, because then the sum is going to be of the subarray is going to be bigger than 0, so that's false. Right. So let's do this again. For I in range 1, length of nums, we're going to pre-compute this. So let's just call this before and after. Nums of I minus 1, nums of I. Let's print before and after so you can see. Basically just going through the pairs like this. Okay. And so now if before modulo 2 is equal to 0 and after modulo 2 is equal to 0, we'll call this current, is probably better, because literally we're just going from 1 to the end and comparing the previous element to the current one. Current modulo 2 is equal to 0, or before modulo 2 is not equal to 0 and current modulo 2 is not equal to 0, then that's bad. We can declare p minus 1 equals to 1, because that means that at the very least, if the guy in front is the same as the current, then we know that the current one cannot be cannot have a good parity. So any subarray that includes this element is going to be bad right away, is going to be false. And to make it easier, maybe we can do it this way, or we can do it this way. Plus 1 I, whichever way, doesn't really matter. It might be easier to look at it in terms of after. So now let's print p. And now you just kind of just want to line it up. So you can see 0, 1, 2, 3, 4. but we want to take everything previously. So this is great because, or actually 0, 1, 2, 3, 4, this includes a 1 because then that's bad. For here, let's say 0, 1, 2, this is bad because it includes a 1. 2 to 3, there's no 1, so it's true. So just to test this out, let's declare or let's iterate over queries again. And let's call this start and end is Q0, Q1. Okay, so that's the start and end. And then let's call current equals to P of S n plus 1. Let's print current just to make sure we got the right boundaries. Okay, 0, 4, that's good. So now we just want to say if 1 is in current, result.append false, else result.append true. That's still too slow, so I'm going to show you a better way, but just to validate this, because it's easy to mess up like the boundaries. So again, you're going to get time limit exceeded, I think. Oh, okay. Maybe we didn't do it correctly. Oh. That's because the current guy, not the one after. Because the after one, the one to the right, means that the current one is bad. Right, so, okay. Yeah, this is easy to get wrong, so I'm going to go ahead and try to debug this. It took me quite a bit of tries, I'm not going to lie. Let's print current. Quite a few tries. Okay. So this is not right because okay. So it's supposed to be true. Maybe it's supposed to be like this. Okay, so it's actually one less. There we go. Just got to play around with this a little bit, but now at least we get time limit exceeded. Best way is just to print out what current is. Okay, at least we're getting that now. Okay, cool. So 0, 0 is nothing, right? That's how you know you're doing it right. 0, 2 is not including this guy. Not including this guy is 1 of a difference because only index 2 is included, right, of the P array. So now instead of doing this, let's go ahead and let's accumulate P because we're going to use prefix sums. And then let's call, let's say, left and right is going to be, well, if S is less than or equal to 0, as with, with prefix sums, then now is just going to be total of E minus 1. Else now is going to be total of E minus 1 minus total of S minus 1, because again, if you want to get the sum of like this subarray, then it's just this guy minus this guy in the accumulated array. And now we can say if now is bigger than 0, then append false because there's 1 somewhere in there. Otherwise don't. Let's say this is, no, it's got some edge cases, just got to play around with this a little bit. Let's print current. Let's print S and E. 0, 0. So E minus 1, S minus 1, right? Yes. Well, no. E. Okay. Now it's going to be total of E minus 1 minus total of S, or S minus 1. So let's see, this is going to be, let's print total so we can get a better picture. Total's just 1, 1. So, well, this is nothing, so that's fine. Oh, so if e minus s is equal to 0, then result.append true, and then continue, because there's nothing there. Okay, so cool. Then I did it a little different than how I did it an hour ago, so that's great, because there's nothing in there, so that means it passes. It's true, you can append because there's no violation. Oh my god, really? Strange. Oh my god, okay. Oh, we don't need this because we already have the indexes. There we go. That's what saves a lot of time, because creating like a sublist is actually going to take a lot of time. So anyways, just really happy that I solved this on my own, and thank you for watching and stay tuned for more.